I'm super excited to introduce today's keynote speaker, Steve Seitz. Steve has an extraordinary ability to see around the corner, to recognize emerging opportunities in computer vision imaging long before they seem possible. So Steve is a professor of computer science and engineering at the University of Washington, and a Google Fellow and VP leading projects like Google Beam and Flow, which is Google's generative video creation efforts. Steve's ideas have profoundly influenced photography and communication as a whole. He has led teams that created Project Starline, Jump, VR180, Lens Blur. So these are innovations that have changed how we capture, share, and experience content images, from immersive virtual reality to communication across a distance. So his work really continues to define what is possible. He splits his time not only between the University of Washington and Google, but also a vastly successful YouTube a channel which covers graphics in 5 minutes that I'm sure you all have seen, and that shows how much of a reach he has. So having such a tremendous reach, Steve's work has earned some of the highest honors in the field of computer vision and imaging, including not only 1, but 2 David Marr prizes at ICCP, a CVPR Best Paper Award, an ICCP Helmholtz Prize, recognizing work that has had lasting impact on computer vision, and he is also an IEEE Fellow and an ACM Fellow. So please join me in welcoming Steve Seitz.
Well, thanks for the very kind introduction. Also, just for inviting me. The last time I was here in Princeton, I looked like this. I'm the guy on the sort of surly teenager on the right in the blue jacket. So that's my father. He was a professor of math at the University of Oregon, but doing a sabbatical at the Institute for Advanced Study right down the road here. And I have fond memories walking through the Princeton campus every day on the way to school. And I actually learned how to program at Princeton High School. They had a room full of, I think it was Apple IICs or maybe Apple IIes at the time. And then the other kind of interesting computer-related moment I remember is when the first Macintosh arrived at the Princeton University bookstore, and I would go after school and just hang out, a super geek, with the Mac until I could convince my parents to buy one. Anyway, that's how old I am, unfortunately. So as Felix mentioned, I have this YouTube channel of 5-minute videos, and basically the idea, these are basically computer vision, computer graphics, perception, generative AI, 1 or 2 science videos. It's sort of like a side hobby of mine, but the main thing is I figured out how to condense an hour's worth of material into 5 minutes. So it's a little weird giving a 45-minute talk because I feel like I should be able to cover 9 hours of material in this talk. By the way, show of hands, who has seen one of these videos? Raise your hand. Okay, so maybe about a quarter of you. So for the rest of you who haven't seen one, I'll give an example. I won't show a whole one, but I'll show part of one later in this talk. All right, so if you want to create a masterpiece, there are a number of things you have to do. You basically have to learn how to paint or sculpt or whatever it is. You have to have the idea for the piece that you want to create. Then there's typically some form of planning and creative exploration while you figure out exactly how you want to do it. And then then you basically just execute the piece in its final form. So Leonardo kind of went overboard on these things, as you probably know. So the learning phase for Leonardo was basically to understand human anatomy to a point where he dissected dozens of cadavers over the course of his lifetime, and really was sort of discovered new things about anatomy that hadn't been known before. The body, the face, and then the one on the right is the lips, which is a funny one. So, of course, he perfected the smile, right? The Mona Lisa smile. But to understand how to smile, you have to understand how lips, biomechanics. And so it turns out you can independently move your lower lip from your upper lip. So you can try it now. You can move your lower lip independently, but you can't move your upper lip. So try moving your upper lip while keeping your lower lip stationary. It's impossible, right? So Leonardo knew this. It's kind of one of the many things, kind of funny things he discovered that may be relevant to smiles and so forth. He also figured out lighting and shading and all that stuff. So on the right is his study of shadows and penumbra. On the bottom, you can see basically BRDF of cloth. And then kind of like painting techniques for shading, like cross-hatching on the top, and Sfumato is famous kind of like shading technique for soft boundaries on the bottom. So anyway, he really mastered all of these things. And so for him, learning to paint was like learning everything about humans and reflectance and shading and everything, right? So that's a lot. Okay, so the next thing is you have to come up with the idea for the piece that you want to create. And so The Last Supper was a commission, actually, so arguably someone else's idea, although. So this is the mayor of Milan, and he wanted Leonardo to paint something in this building. So that's where The Last Supper was done. Now, side note, during the war, it was almost destroyed. So a bomb landed just like feet away from The Last Supper itself and destroyed the building this is the room that The Last Supper is in. The only reason that the painting survived is that it was covered with sandbags. Fortunately, it's sort of a miracle that it survived. Okay, so what's the idea behind this painting? Well, it's basically the moment that Christ shares that someone in the room is going to betray him, right? And so everyone reacts in a different way. And there's sort of a micro story about every person's reaction to that news. So that's kind of the idea that he wanted to convey. Now there's a lot of, planning and preparation, months of preparation for this piece, in the form of like mini sketches like this. This is one of the surviving ones of basically here are her studies of the different disciples to sort of plan how he wanted to paint them. And he famously went around town figuring out whose face was going to be on each disciple. So at the time, it was traditional that the faces were sort of aspirational. They're not like real people for religious figures. But he basically broke that convention and wanted to find real people to base his images on. And in the case of Judas, he actually visited the local prison and wanted to find the most hardened criminal face to kind of represent it. So anyway, that's one example of his sort of creative exploration. Another example was perspective. Of course, if there's actually he put a nail in the canvas right at the temple of the Christ figure, and he wanted that to be the kind of point where all the lines converged, the perspective lines, and so basically he did that by this nail and then attaching string and then pulling the string out, and that defined the vanishing points and all the lines in the image. So he uses devices like this to plan out the piece before he actually painted it. Obviously, this is a recreation using a nano banana. All right, so this creative exploration phase, and then finally the execution phase, which was not as good in this particular painting. Typically frescoes are done on wet plaster, so you basically paint directly on the wet plaster, and that it sort of, as it hardens, it sort of fuses with the paint and then preserves it basically. But he wanted more time to do it, so he created an experimental approach using on dry plaster with a mixture of oil and tempera, which turned out not to be a good idea, and then it started degrading relatively soon after it was painted. So the execution matters, but it managed to be still preserved in some form or another. All right, so by analogy, I want to talk about generative imaging and the steps that a generative system would go through. And so what's the first generative image system? So I would argue it's basically the brain. We think of our eyes like cameras, but they're not really cameras. And it's really our brain, which is creating the image that we see. I mean, a very simple example is like, we have two eyes, but we only see one image, right? So obviously it's doing something, but there's a lot more. And to give you kind of a flavor of some of that, I'm going to show half of my, my color perception video. So this will be about 3 minutes. And this is kind of a brief tutorial on the retina, basically.
Hello, everyone. Let's talk about how we see color. Eyes are a bit like cameras. They both have an aperture, a lens, and a shutter. Well, kinda. And of course, a sensor. Zooming into a camera sensor reveals a mosaic of red, blue, and green elements that capture different wavelengths of light. The very center of your retina contains densely packed photoreceptors. It looks like this. It's called your fovea. It's a bit like the camera sensor, but less regular. I notice that there are not as many blue dots on the left. You don't see blue in the very center of your visual field. But this is just a tiny part of your retina. Let's zoom out. This is the world's first rendering of the complete retinal mosaic. I've included all 100 million photoreceptors. As we move away from the fovea, there are fewer cones. Let's zoom out to see the entire retina. This is a 20 gigapixel image. It's hard to see details at this resolution, so let's switch to a lower res schematic. While the fovea is just a degree or two, your eye has a field of view of 160 degrees. That's incredibly wide. And there's a lot going on here. You have a pretty large blind spot to make room for the optic nerve that carries information to your brain. We basically have two visual systems, one that operates during the day and another at night. Why do we need both? Well, our early ancestors spent half of their waking hours in the dark. To see in low light, humans evolved photoreceptors so sensitive that they can measure individual photons. These amazing sensors are called rods, but they only see in shades of gray, so you don't see much color in low light. We have nearly 100 million rods, which is kind of overkill as there's not much to see at night. So our visual system pools the responses of many rods together. This is like having a camera with big fat pixels. In reality, the pattern is more like this, with lower density in the periphery. And when we look through our rod camera, we see an image like this. You'll notice there's a hole in the very center. This is your fovea, which has no rods, only cones, which shut down at night. There's also a hole in your blind spot, but your brain fills it in with something plausible. All right, so that's how we see in the dark, using rods. The rest of the time, we rely on our cones. Cones are cool because they let us see in color, but we don't have that many, and they are concentrated in the fovea. So when you look at this image, what you're actually seeing looks more like this. You have to move your eye around to scan in the scene. These movements are called saccades, and you do a few per second. Your brain then fuses these details into a composite image. You don't see this composite directly. It's created by your brain.
All right, so that's about 3 minutes. The rest of the video talks about color, like what is color, and the cone receptors, and talks about the blue dress illusion and a bunch of other stuff. So, but the point is that your brain is really creating the image that you see. It's doing a lot of in-painting in your blind spot. The color sensors are sparse, so it's in-painting as well between them. And it's really kind of generating the image that you see. All right, so that's your brain, but how about the first modern kind of generative method in computer science? Well, this is arguable. I'm sure there's a lot of candidates, but I like to think of Efferson Lung as one of the first methods. Who here knows this paper? Raise your hand. Probably about 10 people in the room, which is depressing. Anyway, this is a fantastic paper. You should all go read it. Basically, I'll describe it. So basically, the goal is you're given a reference image or a part of an image, like these bricks, and it tends to be a repeating pattern is where it works best. And the goal is to generate the rest of that image. This is basically Alyosha Efros's, first big paper. So imagine you've generated the image so far, shown here, and then the goal is to generate that white square, the next pixel in the series. And the algorithm is very simple. You're going to consider a window around that pixel, square window, and only a subset of those pixels are already generated. So you're only going to consider those pixels. And then you're going to find the best matching window elsewhere in the reference image. And maybe there's multiple ones and you'll randomly choose one, but suppose there's just one. So then I'm going to pick the center pixel of that window, which is red brick color, and I'm going to paste it into the new pixel position. So I've just generated one pixel. So now I'm going to move the window over and do the same thing. So if you think about it, this is essentially, this is definitely autoregressive. It's generating based on the stuff that's already been generating. It's conditioned on the pixels that have already been generated, in this case in a small window, but the window could be as large as you want. So it's really kind of, like a transformer-like architecture, at least the conditioning part of it. Anyway, so this is I think of this as part of, the birth of generative imaging. And so if you think about this process, Efferson Lung is kind of skipping, most of it. There's no learning, there's no idea, there's no creative exploration. It's just execution, right? An algorithm that fills in pixels. It still works well, but it's interesting. It skips all these things. All right, so the next, maybe it's not the next, but another landmark that I think of is StyleGAN. Who here has heard of StyleGAN or know of the paper? Okay, a lot more people, that's good. This actually isn't StyleGAN, but it's the paper before that, the predecessor, Progressive GAN. And this is really the first time I think that many of us saw images of people that we couldn't tell were not real, right? So it's like, that is a real person. No, it's not. It's computer generated, and that was an amazing thing. Now it's obviously, you can do that. But they all look kind of like celebrities because the database is based on celebrities. So it's trained on this database. So basically this is, I'm not going to go through the GAN architecture, but effectively it's adding the learning component in because it's training on a data set of people in this case. But we're still missing the idea and the creative exploration. So the next paper I want to mention, and this one probably blew my mind even more than the others, was the original DALL-E paper from OpenAI, where they generated an image using a transformer with by adding image tokens. And this is part of why this blew my mind is essentially NLP folks generating images, right? But they're generating it the same way you would generate text, which doesn't seem like it would work. So just think about it this way. You could think about an image as, words on a page, right? With the word saying what the color is, right? And then you just generate these left to right, top to bottom, like you would with any other, transformer autoregressive thing, right? Why in the world would this work? That's crazy. But if you interpret these as the colors themselves and you up-res it, you get the raspberries, right? And that's basically what they did. They didn't use they didn't spell out the name of the color. They used these so-called visual words where they had a bunch of patches that were quantized to numbers, but essentially the same thing. So it's literally they're generating an image from 1,000 words, which is mind-blowing that this works. And really this was the thing that started the whole generative AI image and video and all this other stuff coming next. I mean, now it's diffusion, but it's basically variants of the same thing in many ways. Okay, so here, the key thing, they're adding the idea, right? So the fact that it has a LLM head means you can express whatever you want in text. You can express that idea and it will actually generate it. And that's an amazing additional capability. And then just kind of a few more landmarks on the image generation since then. Nano Banana, I mean, the reason why I'm bringing this, there have been lots of other image generation techniques, but this sort of figure generation, this exploded diagram is, before this sort of stuff existed, you could argue that these generative AI methods were just playing with pixels, right? They were basically running statistics and rearranging things and recalling from memory, but clearly there's some amount of reasoning ability in these models, right? So stuff like this really, breaks the hypothesis that it's just like messing with pixels, right? So this stuff is incredible. Of course, Sora, that was like the first time we saw videos like this. This is the drone-generated video of a gold rush scene. Incredible. It just looks like, oh, now I'm transported back in time. Obviously, there were no drones back then, but somehow, it still works. It's sepia tone, and anyway, this is another example. I'll show you a little bit more on the video side, and I'll show you, since I'm also at Google, I'll show you the Google version of this, the latest model called Omni, and this is also a tool that my team developed called Flow, which is a tool for creating content using generative AI. So here's the Omni model, and I'll just show you, some first few examples. So this is kind of fun. The prompt is when the person touches the mirror, it ripples. So you can do stuff like that from regular video. You can turn your hand into a magnifying glass. Let's see, what else? You can remove objects, obviously, remove the violin. This one's pretty cool. So it shows the sound capabilities. So it can do not just physics, but the physics of the sound is pretty compelling. So it's hitting blocks and the bell, and it's all synchronized. So the fact that the model can do all this is pretty cool. All right, so why don't I go back to, I'll kill this and go back to the presentation. Yeah, humans and AI. Let's do it. All right, so the next thing I want to show you is world models. How many of you have played with a world model? Few hands. I think they're relatively new. I think that number of hands will go up. But they're kind of cool. So I'm going to show you Project Genie, which is Google's world model. Let's see, where is it? No, it's not it. Somehow my Chrome window disappeared. Desktop 3. Yeah, that's it. Thank you so much. Glad to have some other people in the room. Okay, so this is Project Genie. So I'm just going to click on Create Your Own. And so you can basically type in whatever world you want, and it will generate it. So I'm going to do Princeton University in deep powdery snow, just to give a contrast with today. And then the character can be whatever you want. What kind of character do you want? Tiger. Let's do a tiger on a snowmobile. And let's make it nuclear powered just for fun. So it's a little faster. And then let's add some other things in the snow, like an object or an animal, or any ideas? Chocolate chip cookies. Okay, giant chocolate chip cookies. See how this works. And I'm also going to, let's see if this works. I want to center the viewpoint on the snowmobile, because sometimes it doesn't do this, and it doesn't work as well if you don't do it. So let's try it. So now it's going to call Nano Banana, the image generation tool, and generate an image of this idea. And that image is going to be used as the entry point into the world. So it works a little bit better, and then you can iterate on the image if it's not quite right. So it should come up in a second. And then if the image isn't quite right, you can modify it. So in this case, there's a tiger. Whoa, it looks like, is that really? Looks like a person holding a tiger. Okay, so no person, just a tiger driving. And I only want to see and I should see back of the snowmobile, not the side. You can see the chocolate chips though. Okay, hopefully this will work. So this is generative AI, right? It doesn't always do what you want. This is also kind of nice why it starts with an image, because it's easier to iterate on the image, and then once you get it right, then you're going to use that as your entry point. Yeah, well, it's still not the right viewpoint, but let's just try it and see if it works. Sometimes when it's a side view, the controls don't work as well, but hopefully they will. Let's give it a try. Okay, so now it's creating this world, and I'm going to navigate this world by using the keys on the keyboard. WASD, just standard game controls. And it's like a video, but this video is controllable. So in real time, I can control it. So now you're in this world. So if I press A, it moves to the left. If I press D, it moves to the right. If I press W, it goes forward. So kind of a bizarre scene. So it looks like I can go through the cookie, which is kind of nice. Let me change the viewpoint so you can see kind of there's my tiger. And you can also see the tracks. So you can see the tracks that it remembers the tracks. So it actually is modeling the physics of the motion, and it has memory. Let's see what else we can visit around here. There's no audio, that's correct. And so let me see if I can jump over a cookie or something. So there's only 60 seconds, so there's only so much you can do in 60 seconds. So I probably won't have time to go up one of the buildings. You can actually climb one of the buildings sometimes with the snowmobile. Depends on the particular mode. So you get a better view from the top. Oh no, 60 seconds ran out. Okay. All right, so that's Project Genie. So let's go to back to the slides. I'll show you a few other examples. If you wanted to literally be Princeton, you could also do that, because now you can ground it in Street View. And so, so here's, I didn't do Princeton, I did Yosemite. It's a Street View pano of Yosemite. So now if I say create world, I'm just going to show a recording instead of playing it live. I'm a dragon in Yosemite. And then, if I launch start flying, you can see Half Dome over there. And this is all, conditioned on the panorama itself. And so it's a relatively realistic rendering of Yosemite in this area. Okay. So, and then because it's Gen AI, you can style it however you want. So maybe I want to see Yosemite after a sandstorm. Okay, so then you can do that. And so now I'm flying around Yosemite after the great sandstorm of 2026. Or maybe you want to see it after the great flood. Okay, so now we're underwater. So this is apparently a dragon that can fly underwater with these bizarre sea creatures. I'm not sure exactly what that is. But you get the idea. So anyway, these models are kind of crazy, very cool. This is one of my favorites. So this is like New York 1900s era film noir style rendering. And it's an astronaut with a jetpack. And so, there's people walking in this scene, old style cars. In this particular world, you can run through walls, which is fun. So here I'm running through this wall. And it's creating this on the fly. So it just created this kind of inner alleyway-like environment just from scratch, right? Because I decided to go in that direction. But it has memory, so when I go back through the wall, it puts me back on the original street that I was on. And I have this jetpack, so let me just activate it. Takes a while to learn how to use a jetpack, so bouncing off walls a little bit in the beginning. But I'm going to get on this platform. It's unclear exactly what this platform is for, by the way. It's probably was supposed to be a train track, but it's not exactly a train track. Realistic landing. And now, again, it's creating some version of the skyline, New York City skyline. Because I'm up there, it had to create the skyline. And now I'm going to kind of, go higher, and I don't know, why not? Okay. So anyway, that's Genie. It's pretty cool. And this is live. I think you have to have the Ultra or the more expensive plans to try it out on Google, but it's available. All right, so so far I've these models are incredible, but they're missing a step, which is this creative exploration step. And so by analogy, we saw Leonardo, but another example of creative exploration is Saturday Night Live or any kind of show, right? So this is Saturday Night Live writer's room in New York, and that's Lorne Michaels, the creator of this show, in the back. And they create a new show every week. And as probably many of you know, this is how it goes. Like if you're creating a new show every week, you have to be on your toes. So on Monday is the big concept pitching phase. So they come up with a zillion pitches, ideas of things. People around the room come up with different ideas. And by the end of the day, they have 30 to 40 sketch ideas. Okay, but these aren't defined. They're just kind of one-liners, basically. So then on Tuesday, they write all the scripts for these things. And they pull an all-nighter to do it, just exhausting, right? So develop the characters, write the dialogues, and the scenarios and all that kind of stuff. Then on Wednesday, they do a table read and decide which of these scripts are keepers and which of them make the cut and which of them don't. And then for the ones that make the cut, on Thursday, they start building sets and costumes and then also iterating, rewriting the sketches and so forth to actually work in a physical environment. Then they do, on Friday and Saturday, they do dress rehearsals. And so they test these in front of a live audience. And based on what the audience thinks, they do more cuts, in or out, and then also more iterations. And then the final show is on Saturday. And of course, the after party is important too. All right, so this is an example of creative exploration. You're trying a bunch of stuff, you're iterating. Lots of work goes into this. But you can imagine an agentic version of this, or a version of similar process. So imagine you had agentic sketch writers, and they may specialize, right? So you might have one agent that specializes in sarcasm, another with physical comedy, et cetera. And you generate a bunch of sketch ideas. Then you go through like an agentic, generate, critique, edit loop. And you can iterate many times until you get sketches and scripts, actually, which are pretty good. And so you generate a bunch of scripts. Don't necessarily have to pull an all-nighter because your Claude or whatever is doing it for you. Then you generate assets like storyboards, and you can iterate on those as well. And then turn the best ones into video segments, and then composite them into content. Anyway, so this is an example of a system, and my graduate student Susan Hong built a system like this with my esteemed colleagues Brian and Ira, and the goal was to generate a comedy sketch similar to like a Saturday Night Live, but out of using Gen AI tools. So I'll show you one sketch, and remember, this is created from a system that can only create 8-second clips. There's no consistency between them. The system has to build all of that stuff. So here's one of the comedy sketches. Actually, before I do that, one more thing on this particular system. On Susan's system, you provide as input a character description. And so in this case, the character's name Haydal, and then a short snippet that describes the character. So it's a PhD student in computer vision, likes lattes, enjoys conferences and free t-shirts, and then a sound sample. And then you can do one or more characters, in this case just one. It'll generate the rest of the characters and then the sketch. So here's the sketch.
Are you the person selling conference t-shirts on the campus forum?
Depends who's asking.
It's just a t-shirt.
Just a t-shirt? Kid, we're talking about a DeepMind 2019, only 50 in existence.
Boss, we got company.
What's your offer?
I have $20 and a Google I/O 2018 shirt, medium condition.
Google I/O? That's amateur hour. I wouldn't trade a NIPS 2017 for that.
The DeepMind requires 3 references: size verification, proof of attendance, and a character witness.
I just want to wear it to lab.
This isn't about wearing. This is about status. My DeepMind has appreciated 40%.
Irregular stitching. Could be counterfeit from the 2018 reprint.
There was a reprint?
That's how we separate collectors from tourists. We also check the tag font. See how the I in I/O is slightly serif?
Which conferences did you attend?
NeurIPS, ICML, and a workshop on transfer learning.
A workshop doesn't count. You need at least 2 major conferences and a poster presentation.
I had a poster.
What was it about?
Improving model efficiency.
Everyone improves model efficiency.
What's going on here?
It's the feds!
Feds? On-campus security. Why would I be federal agents? You're shining a flashlight at us in a parking garage at midnight. That's my job. What's in the bags?
T-shirts.
Why are you trading t-shirts in a parking garage?
They're rare, collectible.
They're free. I get them at every event. I have 80 in my office. You attend conferences? No, I work the registration tables. They give them to me in bulk. I use them for car wash rags. Car wash rags? The 2019 DeepMind one's particularly absorbent. You want some? I've got a whole filing cabinet back at the office. There's also a stack in the Lost and Found from 2017. Nobody claimed them.
What about the DeepMind?
That one? Yeah, take it. Already used it twice. Fair warning though, there's a coffee stain on the back.
All right. So that's cool. It's not bad, right? I mean, obviously artifacts. It's not hilarious, but there are definitely some laughs and chuckles. So we did a user study, and the system can generate lots and lots of these. And so people basically classify them between slightly funny and moderately funny, which is actually not bad for first generation system like this. But more interestingly, if you compare this with professional human-produced content like actual Saturday Night Live episodes and so forth online, it's only slightly less funny than the professional content. And so over time, you can imagine these lines moving further, like any benchmark, further to the right. All right, so now to be fair, it's also hard for humans to produce funny content. These are the Saturday Night Live ratings over time. On the far left is when the show first started about 50 years ago. And the far right is the more recent ones. And you can see on the ones on the far left, there's a lot more green, which basically says that they were funny. But the show got pretty bad in the center, in the middle, and then gotten a little bit better more recently. So this is a hard problem, and LMs are notoriously not particularly good at comedy. Now, do I think that, this is the humans plus AI slide. Do I think that all content will be generated automatically in this form? No, I don't. I think the best content, stuff we want to watch, will be humans working with these AI systems. Like imagine instead of Saturday Night Live, having to stay up all night coming up with these scripts, you could actually use AI systems. Obviously, this is controversial right now. But I think over time, these systems will be seen more as a power assist that can help us in creating compelling content. So I think the best content will be AI assisted. So I think this area of creative exploration, this is the iteration and trying to come up with new ideas and trying different things out. This is super important for creating good content. This will be a really important thing, plus like having critics that are grounded in the real world and aligned with humans. I want to talk about a couple of other areas for future work. A number of speakers over this, like Payman and others, have mentioned sort of authenticity as like an important goal going forward. There's another version of that, which is accuracy. So in my own videos, I really want to get to the point where I can use. It takes me like weeks to generate each one of these videos. I'd love to be able to do it in days or hours, right? And using AI to help me. And so far, it hasn't been useful enough. And that's kind of my benchmark of like, when is it going to get to the point where AI can either generate or help me with these videos? And I'll show you some examples of why this is hard. So, this is the one I just showed you. This is the retina mosaic that I built. So this is actually, so this didn't exist. I wanted like a representation of what the whole retina looks like, and there is none. It just doesn't exist. So I had to make this myself, and so it's this 10 gigapixel image that you can zoom into and see the fovea, and it's like all that stuff. So I basically had to generate this, but I wouldn't trust Gen AI to just generate an image of the retina. It wouldn't be accurate enough, right? I had to read a bunch of papers to understand the literature and what's known about the distribution of rods and cones and the exact position and size of the blind spot and all that kind of stuff. Okay, so that's kind of one example. Here's another segment I did for one of the videos on splines. I wanted to show how back in the old days, like splines, the idea of a spline came from like shipbuilding like a few centuries ago. And the way they defined curves was they got these wooden strips and these duck weights. They're called duck weights. They're really heavy. And then they use them to pull the strip in different directions to create curves. And so as you do this, it creates a curve, a nice curve. And then you can trace out that curve on a piece of paper, and that defines your curve. So this is how curves were designed and ships and stuff like that. Now, this is often taught in computer graphics class, but there are no images of duck weights. There's no images or demonstrations of this process I could find online. And that means that Gen AI systems also can't do it. In fact, there's only one company left in the US that sells these things. So I had to order a set of these things from this company. And then once I got them a few weeks later, I spent a couple days in hardware stores trying to find strips of wood that actually had the right tensile properties to create this 10-second video. So I literally spent like a couple months on this 10 seconds. So this is another example of something kind of accurate that would be hard for a model to do. One more example, I think. Maybe I have two. Oh yeah, so I did a video on the aurora just for fun, and I had to do this simulation of atoms in the upper atmosphere in order to show how on Earth oxygen atoms don't have time to emit photons, but in space, because they're not bouncing with they're not intersecting other atoms. Anyway, so stuff like this again took me weeks to get the exact motion of the molecular, kind of when they fuse, like what happens under what conditions. I think I'll skip the reinforcement learning one, but there's a bunch of examples where it's kind of hard for these models to do it. I wanted to end on a quote, since I'm out of time. Since Payman quoted Stephen Wright, who's also one of my favorite comedians, I wanted to copy him and end with a quote by Stephen Wright, which is vaguely related to generative AI and computational photography. Anyway, that's it. Thank you very much. Yeah, Mark. I don't like the sound of that.
In a generative model basically rehashes its training data and can make connections between different aspects of its training data. One could say that human creativity is the same, but somehow maybe it's a bit different. How do you think that's going to play out long term? Is it going to replace human creativity? Can we mimic it exactly? What's missing?
Yeah, so I don't know the answer to that. I think that basically we yearn for kind of human connection and influencers and real actors and so forth. So I don't think that it's going to replace creativity. I think it can mimic creativity. It can help creativity. I think the ways in which, I've talked to a number of artists now through these different projects, and there's obviously like some artists who don't like this technology and others that are embracing it. And the ones who are embracing it are sort of using it more as a power assist of, I have this idea, can you help me improve it? It's sort of like a sounding board. Anyway, so that's kind of how I see it playing out, as more of like the sounding board collaboration partner. Obviously, it can also create and come up with its own ideas. The question is, will we want to watch robot-generated content? Probably in some contexts, yes, for certain types of explainer videos, if there's some utility there, but probably not if it's like, if it's, the way that we appreciate content today, which is like actors that we're familiar with, like musicians that we follow, things like that.
One other very quick question. Saturday Night Live is topical. Will you be able to retrain or post-train the foundation models fast enough to generate content for next week's Saturday Night Live?
Well, I mean, you don't necessarily have to post-train, right? I mean, the context windows are pretty massive now, right? So you can feed in a ton of context without retraining the model. Let's see, there's a question up there, one here.
Hello. So the duck weights, I think, are a really interesting example of, like you're saying, that there's no YouTube videos of explaining how to use them and so on and so forth. So in the video generation model, that's probably not inside of its brain. I think it kind of relates to like the big question of robotics right now, which is, do robots need to squish and pick up things to learn what physics is? Or can you just watch 8 trillion YouTube videos and figure out all of physics from that? Do you think, like, if you just took a video gen model and you explained it in English very clearly what duck weights are and what the rough tensile strength of a piece of wood is, can it just generate that?
So this is a key point. I think that my example, the point of a bunch of these examples, like where I actually coded up some simulation, Claude could do all those things, right? So like diffusion models can't probably today. Maybe they'll sort of do physics, but you can Claude code any sort of simulation, right? So the next question is like, what are these models going to be like going forward? They're probably not just going to be like diffusion models that only generate pixels. They're probably going to also involve, coding. If I want physics, let's actually create a simulation. And for a lot of the content, that's what you want, I think. Other one up there.
Great talk. I thought the video with the kind of comedy skit was super interesting. My question is I feel like in today's atmosphere, there's a lot of like AI slop out there. And so, I mean, you showed it even with like the SNL, like human writers, they bomb sometimes, they do great sometimes. Do you think that we are working towards models that will be able to distinguish between like high quality content that people will actually want to see versus just like generic AI slop?
Yeah. So a couple comments there. Like, absolutely, like, it's so easy to create slop in all forms, like paper slop, bad submissions, bad content. And so there'll be more and more of that. So we'll need better curation systems. I mean, there's a lot of human-generated slop on YouTube, and like you were saying. But it does put more pressure on curation. But the other part of that is I do think that the models will get better, right? And so they'll be, by default, when you generate something, it won't be as bad as it is today. The models will start generating actually really compelling content. Sort of in the way that we're almost there for images. I think the average image generation is actually really good, even if it's not exactly what you want.
I was wondering, so you were saying that you didn't find the generative models useful in your experience, and how much of that would you attribute to the capabilities of the model versus the way that you interact with the model or the way that you can control
That's a good point. It's a good point. I think my workflow may not be good enough yet, and I could be using the model. By the way, I sort of I stopped creating these videos like a year or two ago just because I haven't had as much time recently. And so, you know, if I did it today, I'd be using Claude or other coding models a lot more. But yeah, I definitely do think the workflows could get better, the models could get better. But I think a lot of my problem is that for the things I want to convey, there's a certain precision in the visualizations I want. That every once in a while I will generate an image and use that in one of the videos, but that's about it.
As a quick follow-up, do you feel like you would have been able to, with like a model that sort of had the sufficient expertise, control it in the way that you wanted with natural language, or do you feel like you would need some other way of interacting with it?
It's a good question. I think you know, I certainly would like to use natural language for a lot of it. I mean, the way I do these videos, I start with a script, right? And so I would like it help generating the script. That's one thing. But then it's basically how to animate that script. And so that's kind of text to video, almost literally. So I would like to use natural language. There are probably places where I, swap out the font or move this thing to the left. Direct manipulation would be nice, or other mechanisms.
Thanks for the great talk. I have a question here at the back. So since you talked about generating like SNL videos, right? So, and sketches. So how do we subjectify object, like these are quite subjective about the humor, right? Or some sort of emotion. So how do we quantify this and give a feedback to the model to basically produce more funny videos?
Yeah, no, thanks for asking. How do you evaluate whether something is funny? So for this particular approach, we had grounded critics, which were grounded on YouTube videos. Basically, what we did was we looked at Saturday Night Live, Key and Peele, a bunch of other like comedy sketch channels, and then looked at ratings for the different skits as sort of a proxy for how funny they were, and then kind of didn't train a critic, but basically grounded these critics on these ratings, so that their critiques would mimic the YouTube ratings. And that's one way of doing it. But you could also do that with a particular person. Maybe there's a particular style of humor that you want. You could have a critic which is aligned with that person. But I think this human alignment part is really important.
And is there a user study as well that you conduct on the generated videos, that how good or bad they are?
Yeah, I showed that towards the end of those graphs saying how funny they are. Yeah, so we did a user study and asked a bunch of different things. Yes.
Thank you very much for the wonderful talk. And you talk about world models. And you see that we try to solve for scientific studies, we try to use physics to solve the partial differential equations, FEAs, which in order to get an accurate answer, and it's very computational intensive because we need a small grid size. And then for the diffusion model, on the other hand, in order to get a more accurate result, it is also very computational intensive. So compare with the physical model and the diffusion model, in order to get an accurate result, which one do you think is more computational intensive?
I think that's sort of an open-ended question. Depends on the physics model, depends on the diffusion model. I can say the diffusion models are getting like cheaper and cheaper, right? And you know, people are coming up with better distillation methods. So I think, you know, the one I just showed you is running in real time. I didn't tell you how many like GPU, TPUs it's using, but you can imagine that there are other world models that are public that run on a single GPU in real time. So it's possible to actually make these pretty efficient. There are obviously trade-offs if you do that in terms of quality and accuracy and all that kind of stuff. But it's hard to say in general because your physics model could be simple or very complicated.
All right, perfect. Let's thank our speaker once more. Thank you.